When we think of Nepal, we tend to think of the snow-capped mountains of the Himalayas, the crystal-clear still waters of its alpine lakes, or the huge expanse of its grasslands. What some of us might not realize is that in the Himalayan foothills, where the climate is much warmer and the landscape much greener, there live a great diversity of wildlife, including the one-horned rhinoceros, the Asian elephant, and the Bengal tiger. But unfortunately, these animals are under constant threat from poachers who hunt and kill them for their body parts. To stop the killing of these animals, battalions of soldiers and rangers are sent to protect Nepal's national parks. But that is not an easy task because these soldiers have to patrol thousands of hectares of forest on foot or elephant backs. It is also risky for these soldiers when they get into gunfights with poachers. And therefore, Nepal is always looking for new ways to help with protecting their forests and wildlife. Well, recently, Nepal acquired a new tool in their fight against wildlife crime. And these are drones, or more specifically, conservation drones. For about a year now, my colleagues and I have been building drones for Nepal and training their park protection personnel on the use of these drones. Not only does a drone give you a bird's-eye view of the landscape, but it also allows you to capture detailed, high-resolution images of objects on the ground. This, for example, is a pair of rhinoceros taking a cooling bath on a hot summer day in the lowlands of Nepal. Now, we believe that drones have tremendous potential, not only for combating wildlife crime, but also for monitoring the health of these wildlife populations. So what is a drone? Well, the kind of drone I'm talking about is simply a model aircraft fitted with an autopilot system. And this autopilot unit contains a tiny computer, a GPS, a compass, a barometric altimeter, and a few other sensors. Now, a drone like this is meant to carry a useful payload, such as a video camera or a photographic camera. It also requires a software that allows the user to program a mission to tell the drone where to go. Now, people I talk to are often surprised when they hear that these are the only 4 components that make a conservation drone. But they're even more surprised when I tell them how affordable these components are. The fact is, a conservation drone doesn't cost very much more than a good laptop computer or a decent pair of binoculars. So now that you've built your own conservation drone, you probably want to go fly it. But how does one fly a drone? Well, actually you don't, because the drone flies itself. All you have to do is to program a mission to tell the drone where to fly to. But you simply do that by clicking on a few waypoints on the Google Map interface using the open source software. Now, missions could be as simple as just a few waypoints, or they could be slightly longer and more complicated to fly along a river system. Sometimes we fly the drone in a lawnmower type pattern and take pictures of that area. And those pictures can be processed to produce a map of that forest. Other researchers might want to fly the drone along the boundaries of a forest to watch out for poachers or people who might be trying to enter the forest illegally. Now, whatever your mission is, once you've programmed it, you simply upload it to the autopilot system, bring your drone to the field, and launch it simply by tossing it in the air. And off it will go about its mission, taking pictures or videos along the way. And usually at that point, we will go grab ourselves a cup of coffee, sit back and relax for the next few minutes. Although some of us sit back and panic for the next few minutes, worrying that the drone will not return. Usually it does, and when it does, it even lands automatically. So what can we do with a conservation drone? Well, when we built our first prototype drone, our main objective was to fly it over a remote rainforest in North Sumatra, Indonesia, to look for the nest of a species of great ape known as the orangutan. The reason we wanted to do that was because we needed to know how many individuals of this species is still left in that forest. Now, the traditional method of surveying for orangutans is to walk the forest on foot, carrying heavy equipment, and to use a pair of binoculars to look up in the treetops, where you might find an orangutan or its nest. Now, as you can imagine, that is a very time-consuming, labor-intensive, and costly process. So we were hoping that drones could significantly reduce the cost of surveying for orangutan populations in Indonesia and elsewhere in Southeast Asia. So we were very excited when we captured our first pair of orangutan nests on camera. And this is it. This is the first ever picture of orangutan nests taken with a drone. Since then, we have taken pictures of dozens of these nests from around various parts of Southeast Asia. And we're now working with computer scientists to develop algorithms that can automatically count the number of nests from the thousands of photos we've collected so far. But nests are not the only objects these drones can detect. This is a wild orangutan, happily feeding on top of a palm tree, seemingly oblivious to our drone that was flying overhead. Not once, but several times. We've also taken pictures of other animals, including forest buffaloes in Gabon, elephants, and even turtle nests. Now, besides taking pictures of just the animals themselves, we also take pictures of the habitats these animals live in, because we want to keep track of the health of these habitats. Sometimes we zoom out a little and look at other things that might be happening in the landscape. This is an oil palm plantation in Sumatra. Now, oil palm is a major driver of deforestation in that part of the world. So we want to use this new drone technology to keep track of the spread of these plantations in Southeast Asia. Now, drones could also be used to keep track of illegal logging activities. This is a recently logged forest, again in Sumatra. You could even still see the processed wooden planks left on the ground. But perhaps the most exciting part about taking pictures from the air is we could later stitch these pictures together using special software to create a map of the entire landscape. And this map gives us crucial information for monitoring land use change, to let us know where and when plantations might be expanding, where forests might be contracting, or where fires might be breaking out. Area images could also be processed to produce three-dimensional computer models of forests. Now, these models are not just visually appealing, but they are also geometrically accurate, which means researchers can now measure the distance between trees, calculate surface area, the volume of vegetation, and so on, all of which are important information for monitoring the health of these forests. Recently, we've also begun experimenting with thermal imaging cameras. Now, these cameras can detect heat-emitting objects from the ground, and therefore they are very useful for detecting poachers or their campfires at night. So I've told you quite a lot about what conservation drones are, how you might operate one of these drones, and what a drone could do for you. I will now tell you where conservation drones are being used around the world. We built our first prototype drones in Switzerland. We brought a few of these to Indonesia for the first few test flights. Since then, we've been building drones for our collaborators from around the world. And these include fellow biologists and partners from major conservation organizations. Perhaps the best and most rewarding part about working with these collaborators is the feedback they give us on how to improve our drones. Building drones for us is a constant work in progress. We're constantly trying to improve them in terms of their range, their ruggedness, and the amount of payload they can carry. We also work with collaborators to discover new ways of using these drones. For example, camera traps are a common tool used by biologists to take pictures of shy animals hiding in the forests. Now, these are motion-activated cameras, so they snap a picture every time an animal crosses its path. But the problem with camera traps is that the researcher has to go back to the forest ever so often to retrieve those images, and that takes a lot of time, especially if there are dozens or hundreds of these cameras placed in the forest. Now, a drone could be designed to perform the task much more efficiently. This drone carrying a special sensor could be flown over the forest and remotely download these images from Wi-Fi-enabled cameras. Radio collars are another tool that's commonly used by biologists. Now, these collars are put onto animals. They transmit a radio signal which allows the researcher to track the movements of these animals across the landscape. But the traditional way of tracking animals is pretty ridiculous because it requires the researcher to be walking on the ground carrying a huge and cumbersome radio antenna, not unlike those old TV antenna we used to have on our rooftops. Some of us still do. A drone could be used to do the same job much more efficiently. Why not equip a drone with a scanning radio receiver, fly that over the forest canopy in a certain pattern, which would allow the user or the operator to triangulate the location of these radio-collared animals remotely without having to step foot in the forest. A third, and perhaps most exciting way of using these drones is to fly them to a really remote, never explored before rainforest somewhere hidden in the tropics and parachute down a tiny spy microphone that would allow us to eavesdrop on the calls of mammals, birds, amphibians, the Yeti, the Sasquatch, Bigfoot, whatever. That would give us biologists a pretty good idea of what animals might be living in those forests. And finally, I would like to show you the latest version of our conservation drone. The Maya drone has a wingspan of about 2 meters. It weighs only about 2 kilograms, but it can carry half its weight. It is a fully autonomous system. During its mission, it can even transmit a live video feed back to a ground station laptop, which allows the user to see what the drone is seeing in real time. It carries a variety of sensors, and the photo quality of some of these sensors can be as high as 1 to 2 centimeters per pixel. This drone can stay in the air for 40 to 60 minutes, which gives it a range of up to 50 kilometers. And that is quite sufficient for most of our conservation applications. Now, conservation drones began as a crazy idea from 2 biologists who are just deeply passionate about this technology. We believe, strongly believe, that drones can and will be a game changer for conservation research and applications. We've had our fair share of skeptics and critics who thought that we were just fooling around with toy planes. And well, in a way, they are right. I mean, let's be honest, drones are the ultimate toys for boys. But at the same time, we've also gotten to know many wonderful colleagues and collaborators who share our vision and see the potential of conservation drones. To us, it is obvious that conservation biologists and practitioners should make full use of every available tool, including drones, in our fight to save the last remaining forests and wildlife of this planet. Thank you.